Hello everybody, we're getting ready to do lesson 6.2, part 2 of pre-calculus math today. Classwork section here, part 2. If you need any course materials, here's my email. And today, 6.2, part 2, Law of CoSines. You got 4 points here that will go into your notebook. And then you got 20 points here on our classwork. So getting into our bell work here. Students and teachers, today's bell work. Evaluate the expression without using a calculator. So we have the cosine to the -1 of, or rather the inverse cosine 0, and then the inverse tan square root of 3. So students, give your students about 3 minutes. I mean, they can knock this out. Okay, back for our solutions for today's bell work, teachers and students. So for number 68, the inverse of cosine 0 equals pi over 2 is cosine 0 because cosine pi over 2 equals 0. So it would equal 0 because the cosine of pi over 2 equals 0. Then the inverse would be pi over 2 for that. And then down here, the inverse of tan for square root of 3 would be square root of 3. So the inverse of square root of 3 would be pi over 3 because the tan of pi over 3 equals square root of 3. So we're looking for the inverse of tan square root of 3, which is pi over 3. Okay? To our lesson today, we start with a notebook entry here, Heron's area formula. So the law of cosines can be used to establish the formula for the area of a triangle. This formula is called Heron's area formula after the Greek mathematician Heron, circa 100 BC. So here is the formula here. Given any triangle, and this goes in your notebook, students. If you don't have a notebook guide, you got to take this down into your notebook. Given any triangle with sides of lengths A, B, and C, the area of the triangle is given by the radical s multiplying by s minus A, s minus B, s minus C, where s equals A plus B plus C over 2. So you add up your sides of your triangle, and then divide that by 2. That equals your s, and then you put that up here into your area formula, and then you multiply s times s minus A, s minus B, s minus C, and then you take the radical of that. And that is Heron's area formula. So let's try one now for Heron's area formula. Example 5. Find the area of this triangle here. So we have our side lengths here. So because s equals A plus B plus C over 2, so when we add these up, we get 168 over 2. That equals 84. So our s equals 84. And so when we plug that into our formula, we get 84 times 84 minus 43, 84 minus 53, 84 minus 72, and then we take the radical of that. And there's your set up there. And then the radical of that is 1131.89 square meters for the area of this triangle. That's pretty cool there. So let's try one. Landau Building in Cambridge, Massachusetts has a triangular shaped base. The lengths of the sides of the triangular base are 145, 257, and 290. Find the area of the base of the building. So you know what we're going to plug in here, right? So let's see. 145, 257, 290 over 2. And then what does that equal? It equals 346. So this is your guided practice up here. You're independent. Am I going to be nice today to do that? I guess I will be. So your independent practice here. So your area using Heron's formula would be, this is your Heron's formula, and then our plug-in here is 346 times 201, 89, and 56 We multiply this out, and then we take the square root of that, which equals 18,617.7 square feet for the area of the base of the Landau building. Okay, another notebook entry. You have now studied 3 different formulas for the area of a triangle. So formulas for the area of a triangle. This goes in your notebook, students. Standard formula, area equals 1/2 BH. Then the oblique triangle, you have area equals 1/2 BC sine A, which equals 1/2 AB sine C, which equals 1/2 AC sine B, or 3, Heron's formula, which we have just done.